One final application of the present value function is to solve what I call the lottery problem. Normally when somebody wins a lottery, they're given a choice. They can either take annual payments for a certain number of time, or they can take a lump sum payment at the very beginning. The lump sum payment is clearly going to be less than the sum of all of those annual payments, and the person who wins a lottery has to decide whether they want that steady income over a long period of time or whether they want the lump sum. So how do you decide? You can use the present value function. In this example, we're assuming we've won a $20 million lottery, which is going to pay off $1 million a year for 20 years. Now, if we could earn 6% on a lump sum and just leave that in the bank, take out $1 million a year, how much money would you have to start out with so that you could do that? In other words, exactly duplicate the performance of the lottery. And so if you win a $20,000 lottery, what we're trying to find out here is if we have withdrawals of $1 million once a year for 20 years and an annual interest rate of 6% and an ending balance of 0, and we do this, it's formatted wrong, let's fix that, the ending balance should be like that, and we're going to do our withdrawals at the beginning of each period. Now, how much money do you have to have up front so that you can withdraw $1 million every year, earn 6% on the balance, and when you get all done, have exactly 0 left? So that's the present value function. So let's go back to our formulas tab here, go to the financial group, scroll down to the P's, choose present value. The rate is going to be our rate per period, and notice in this case the periods per year is 1, not 12. So the rate per period and the annual rate happen to be the same, but that's usually not the case. Number of periods is going to be this. Payment is going to be $1 million. Future value is going to be 0, and the type is going to be this, and click on OK. And it tells me that if I could get a lump sum of $12,158,000, I could put that money in the bank at 6%, take out $1 million today, take out $1 million a year from now, and every year for the next 20 years. And by the time I was ready to take out my last withdrawal, I'd have exactly $1 million left, and I'd be back to 0. So if the lump sum is greater than $12,158,000, then you should take it. If the lump sum offer is less than that, then you should probably take the $1 million a year for 20 years. So this is the tipping point right here.